this, or if you missed something, or if somebody else isn't here. So this is 130 Allegheny campus 130 nursing tutoring for Dosage Calc. And those of you here live, if you have a question, just type it into the chat or raise your hand, and then I'll call on you that way. Just in case I'm in the middle of something, I don't want to disrupt my flow. So I put together these review tips for you, just some things to kind of remember and look over when you're studying these things. Remember, read the question. What is it asking you? If it's telling you to calculate for tablets, pay attention to the tablets in the bottle. If it's capsules, if it's milliliters, if it's units, whatever the thing is asking for, make sure you're paying attention to what you're solving for first and foremost. Kind of know where you're going before you go there. The When we do reconstitution type questions, I'll explain what that looks like. I think I might even have an example of what one looks like, a current one that they will probably be transitioning to over the next couple of years, but I'll get to that when we get to it. You need to know your basic conversions. You have to have these memorized. They will not be given to you. This is the main thing. But if you got it last time, sometimes it's just a matter of getting back into it, practicing, and you'll be fine as far as reviewing the things that you need to review. Rounding rules. Remember that when you are, especially if it is a Blackboard test, you want to make sure you have your leading zero. So if your answer is 0.5, you want to put an answer of 0.5, not just 0.5. So make sure you have that zero in front of the decimal if it's supposed to be there. If your answer is 1, you do not want to put 1.0, or you don't want to put 0.50. You don't want the trailing zeros, okay? When it comes to rounding, it's more specific towards like pounds to kilograms, and then when you're dealing with things with milliliters, even milliliters per hour, if the volume is greater than 1 milliliter, round to the nearest tenth. If it's less than 1 milliliter, then you can round to the hundredth place. Okay. And so I gave some examples of that here. So, like here, let's say my answer is 1.25 milliliters. You would look at the five. The five would tell you to round up. So you would round that to 1.3 milliliters as your final answer. If the answer was 1.24 or 3 or 2 or 1 or 0, then you would not round up. You would leave it at one, you would drop the 4 and leave it at 1.2. Okay. If we have a number that they're asking you to round to the nearest hundredth, the hundredth place is the second from the decimal. So you're going to look at the third space. So if it's a 9, then you'd round that up to 0.97. And if it's 4 or fewer, then you would you would drop that number and just leave it at 0.96. Okay. I don't think you're going to get a lot of those, but just in case you do. The other thing I should mention, and I think I have it listed here, maybe I don't have it listed here. When you're doing your standard like conversions, so like let's say you're converting milligrams to micrograms. If your answer is like your final answer is 0.125 micrograms, do not round that number. Okay. You do not round basic conversions. You only round if if you're changing your units of measure from like the different systems of measurement, meaning you go from pounds to kilograms, or if you go from grams to ounces, like you're not going to do that. But if you go, or ounces to milliliters, like if you're going in between different systems, metric to the US standard system, then yeah, you can round. Okay. But if it's going from milligrams to grams or micrograms to milligrams or vice versa or milliliters to liters, do not round those answers. And you'll see what that looks like in a second. These are some helpful formulas that might be helpful or helpful equations, but those who worked with me last semester or watched any of my reviews, you know that I tend to follow and use dimensional analysis because if you use dimensional analysis and you use it as a tool, not something you're memorizing and trying to remember, but just as a tool and a strategy. You don't have to worry about these different equations. It's just, but something to think about. All right. So you're going to have your standard kind of typical questions, right? Going from milligrams to grams, micrograms to milligrams, milliliters to ounces, teaspoons to milliliters. Let me show you this number two here because I want to show you what I mean by when I say to that you're going to have to do some or not to round your answer. So if you don't recall, when I do this 125 micrograms, and if I'm converting that to milligrams, okay, I want milligrams here. I want micrograms here. 1 milligram is equivalent to 1,000 micrograms. Okay. Now, if you're somebody who just moves the decimal point over, great, continue to do that. And if you're worried about showing your work, just show that you move the decimal point over. That should be fine. But if you're somebody that sometimes, you know, multiplies by 1,000 when they should be dividing by 1,000, this is a good strategy to kind of remind you where things are. And if you are like, well, is that, how do I know that's over? Like that's how that looks. So anytime you just have a number with nothing underneath it, it's the top number. Okay. So I'm going to take 125 divided by 1,000, and I'm going to get 0.125 milligrams. And that is my answer. Okay. I'm not going to round that to 0.13. I'm mentioning that because that is a common error, both in the 110, the 130, 220, 230, a 240 test is rounding the basic simple conversions. Don't round those. Okay. If it's whatever that happens to be, like even this one, when I do this final answer, you're going to hate this 0.075 grams. Instinctively, you want to round that number to like maybe to 0.08 or even 0.1. Don't do it. Leave it as it is. That's the test, right? They want to make sure you know that when you're just doing basic unit to unit conversions, that you don't round those, even though they don't explicitly tell you that. Now, where I might need to round might be in something like this, the 135 milliliters to ounces. So when I'm converting milliliters to ounces, again, I'm always going to show you dimensional analysis just because it just helps with organization in my mind. So we know the conversion here that 1 ounce is equal to 30 milliliters. So if I take 135 divided by 30, I am going to get a decimal answer, I think. So 135 divided by 30. Oh, well, it just gives me 4.5. So I don't need to round anything. So I'm just going to leave it as 4.5. But let's say that was 4.52, right? Then you would still answer it as 4.5. If it was 4.56, then you would round it to 4.6. That's that's the gist of the rounding there. Okay. So anytime you're going from metric to American standard, or US standard or US standard to metric, you might need to round. So let's look at this. The patient's weight in pounds going to kilograms. So I have a 131-pound patient. I know that 1 pound, or I'm sorry, 1 kilogram is equal to 2.2 pounds. So I'm going to take 131 divided by 2.2, and I'm going to get 59.54 repeating. So I'm just going to write out 59.54, and it just keeps going. So 54, 54, just keeps going. I know those look like nines. Those are supposed to be fours. I apologize. All right. So 59.5454. So what I'm going to do is I'm going to look at the four, and then I'm going to ask my question, do I round up or do I just drop the number? And then in this instance, we're just going to drop the number. So my answer would be the 59.5 kilograms. That would be my answer for that question. instinctively, you might want to round that all the way to a whole number, 60 kilograms. But, and I will say for like adult patients, this is probably not a big deal because once you're an adult, you're metabolizing at a pretty like within, probably plus or minus 10% of most adults in that range. But if this is a child, that decimal point kilogram becomes more important. And you'll understand a little bit more when you go through 220, 230 and you do pediatric dosage. You will see that we want to make sure we're titrating and also accommodating for the fact that a child dose is going to be a little bit different than an adult dose. Some of that just has to do with the level of metabolism, but you also wouldn't want to give like, 1,000 milligrams of some, like that might be safe and effective for an adult, but if you gave that same amount to, a toddler or an infant, that could be, lethal, right? It could be an overkill, too much. And that goes for anything. It goes for food, goes for supplements, goes for obviously, and for medications. So I'm going to break from the tradition that I've been selling you about dimensional analysis only for this one problem when it comes to these fluid replacement questions. So at like Boyce and South and North Campus, they actually do like they'll calculate how many like ounces of like a bunch of different things that a patient may have for lunch, and they would just calculate their fluid intake, and then just leave it at that. And maybe at some point, Allegheny campus will also make that transition. Some of that is it's just my fault because I didn't know what type of question they wanted. Um, this one you have to do a little bit more math, but once I show you how to do this, it's really not that challenging. It's just something you have to kind of learn and remember. But what you're going to do is, let's say they're on an IV or they're getting liquids via PEG tubing, and we just want to make sure that their kidneys are functioning properly and we want to make sure that they're voiding appropriately. So that's kind of where this question is coming into play. And so what we're going to do is we're going to look at a couple different things. So I'm going to use my highlighter here. So I have 125 milliliters of output, and then we're going to replace with 40 milliliters. So every time the patient goes to the bathroom, and they void out 125 milliliters or that ratio, you're going to replace it with 40 milliliters. So, like, to keep it simple, let's say they voided 250 milliliters. If they voided 250 milliliters, you're going to give them 80 milliliters of water. Okay. Then it'll tell you that the urine output over the last 4 hours was actually 500 milliliters. So we actually know the actual amount that was voided. And so now we're going to take that number and we're going to have to figure out how much to replace. Okay. So there's a couple ways to do this. You can, I'm going to show you how I would arrange this and order this for or as a strategy, or that you can create your own ratio proportion. You can do this any number of ways. So the way the way I would do this is I would take the volume out. All right, so let's say I have 500 milliliters. That's my actual volume that I have voided out, or the patient has voided out. And I'm going to actually put that over top of kind of, I call it the expected or theoretical output. So I'm going to put what the patient actually voided, the actual. So I usually abbreviate that like A for actual. And then I'll use this as the expected. Okay. So I'm just trying to give you the reason I'm showing you these things here is because sometimes this question might be written out differently. It might say, over the last 4 hours, urine output has been 500 milliliters. For every 125 milliliters of urine output, replaced with 40 milliliters. So it might be rearranged if it asks you that. So it's helpful to know what is the actual output. So when they say if the urine output or if the patient voided, that's the actual. and then the replacement or the expected, that's the number you would want to make sure is below. So, and then I'm just going to multiply by the um, actual volume replacement. Now, where things get tricky and why I try not to, or I kind of deviate a little bit from dimensional analysis, because everything's milliliters. But what we're trying to do is we're trying to eliminate the output milliliters and then only have the replacement milliliters listed here. Okay. And so this would be, so 125, or I'll just put it in my calculator so we're all on the same page. 125 times, oops, sorry, 500 times 40 gives me 20,000, divided by 125 gives me a replacement volume of 160 milliliters. Now, we had this last semester, so this shouldn't be new. I don't remember if it was actually on your Blackboard test or not, but this is something to do. So I've had students over the last couple semesters that would say like, oh, okay, so 500 milliliters, 125 goes into 500 four times, and I'm just going to take that number 4 times 40. That is the right strategy. So if that's something you're doing, what you want to pay attention if you're doing these problems and you're like, it seems like the number is wrong, or it seems like I'm too low or whatever, think of it this way. If the patient voids 125 milliliters and then we would need to replace it with 40 milliliters, and then the patient voids 500 milliliters and we're wondering how much that they're going to need to be replaced, the question I would sit there and ask myself is, well, how many would the number be less than 40, equal to 40, or more than 40? And when we look at this, we can see that the number's bigger, right? So we know that this number has to be greater than 40. So we can do this a couple of ways. I've seen like my kids do this where they will kind of like draw an arrow and be like, okay, well, this to get to here is times 4. And then so I'm going to have to do the same thing to get to here, times 4, right? So whatever we do on the left, we have to do on the right. And that's how we would find that number out if we're stuck. Okay. So I'm just trying to give you a couple different uh, numbers to pay attention to. But let's say, this number was, let's say this was 250 was the replacement volume. Actually, let me do this real quick. I just want to give you another scenario. Let's say this was actually 250 ml for every, oh, that is not what I wanted to use. Sorry about that. Give me 1 second. All right, so let's say I wanted to say that the actual output was 250 ml, or the expected output was 250 ml, and then my replacement was 50. Okay. So this is what's actually getting out. This is what's coming in. Now let's say the patient only voided 125 milliliters. This is where you ask this question. Would this number, the replacement volume, would it be more, the same, or less than 50? You don't need to answer. I'm just kind of getting you through this, but you can see that going from here to here is half. So going from here to here must also be half. Okay. So that would just be 25 milliliters. So you might see that where you're going to get a volume that is less than the replacement volume. That's okay. You're just answering the question. I don't think you're going to have to worry about that. But if I don't tell you that now, it could be something you run into and get upset about. So, anyways, this should be you saw this last semester. It's a repeat question. It's asking about how much dilantin to administer. The only reason students miss this question is because they don't account for teaspoons. So you need to make sure you're reading the question and knowing how much you're administering for that. Okay. So for time's sake, I'm gonna skip down to the flow rate questions now because a lot of these should be repeat questions. But again, if there's something that you just want to refresher on, you can just type into chat or raise your hand and I'll come back to it. But let me get to the new stuff for you guys. Find it. Okay. So these are some of the newer types of questions you're going to get because I don't think we did flow rates last time. So these are some of the newer flow rate type questions. And so what I'm going to do is I'm just going to give myself a little bit of space to write in here. So we have some information. That's perfect. Good. Okay. So a couple things about flow rate. So what I'm going to do is I'm going to write some notes. I'm actually going to start with this one here, and I'm going to write some notes. So before I answer any question about this, let's write some notes. So when I'm calculating flow rate, I need to know a couple pieces of information. I need to know the volume and I need to know the time. Okay. The volume is typically milliliters. The time is typically hours. It could be, so I'll just say, or it could be cc per hour. So cc's and ml's are the same thing. It could be, you could get milliliters per minute. You could be getting any number of kind of variations. Okay. So, so just real quick, I am seeing that someone mentioned that this is going into their first semester, starting. I'm assuming you're starting in the second semester, and that's part of the LPN to RN transition. So, make sure you want to review these math problems as we're kind of going through. If there's something that you don't quite get, and then I'll at the end I'll remind everyone where you can get a copy of this to kind of practice if you were getting it. Now, if you're a first semester student, then you have some time and we'll do more thorough reviews. But if you have to take your test next week, then I want to make sure you're seeing all these things. So just but we'll have some time to kind of review that. Okay, so flow rate is going to be written out as that is volume over time. So typically it's milliliters per hour. It could be cc's per hour. It could be milliliters per minute. But anytime they're asking you to calculate a flow rate, they typically are looking for that. They want to know, do you know ml per hour? So let's do this problem. Now, this problem is actually, believe it or not, commonly missed, not because of its level of difficulty, just because you're so entrained and so kind of like looking to do more math than you have to do for these types of problems. This is all about setup. It's literally putting the volume, typically milliliters, over the time, usually in hours. If it's not in hours, then we convert it to hours. And that's what we're going to do here in just a second. So I'm going to take the volume, 120 milliliters, and I'm going to put it over my time, 90 minutes. Now, when you get to this point, you're already kind of majority of the way through this problem, but you need to convert your minutes to your hours. Now, there's a variety of different ways to do this. Some students will just automatically say, okay, 90 minutes, that's 1.5 hours. So I'm just going to write 1.5 hour and then put that down here. That's perfect. That works great. If you don't feel comfortable doing that, you could also just do a conversion. So what I'm going to do is I'm going to convert minutes to hours. 1 hour, 60 minutes. You know you've done everything right because you'll have eliminated minutes and you'll be left with what you're looking for, which is milliliters per hour. So what I'm going to do is I'm going to take my 120 times 60 divided by 90, and I'm going to get 80 milliliter. That's not right. 120 times 60. Must be right. Divided by 90. I'm going to get 80 milliliters per hour. The other way you can do it is if you take the 120 divided by 1.5, you're going to get the same answer, 80 milliliters per hour. So let's look at another similar question, number 19. So this is a good time. I'll pause the recording here just for a few, like maybe a minute or two. Try and solve number 19. So I'm going to highlight it so we're all looking at the same one. Oops. Oh yeah, that's fine. Sorry. There we go. All right. So go ahead and take a moment, and when you come up with an answer, just put it into the chat, and then and then we'll come back in here. All right. Well, it looks like everyone's nailing it, so good work. Hopefully you took the 375 ml over 3 hour, and then just reduce that to 125 mil per hour. And if you're doing that, you're doing it perfectly right. If you're not getting there yet, just keep practicing. You will get there. Let's look at number 18 now. Number 18 is a variation of a flow rate question where they're asking you to take a given volume, a given flow rate, and they want to know how long will you need to come back and check on the infusion. So again, you can actually do dimensional analysis with this question. You can kind of just rationalize the answer to this question. So you have two pieces of information. You have the total volume, 500 milliliters, and you have the infusion rate, 125 milliliters per hour. And what we're trying to do is we're trying to eliminate the milliliters and get left with just how many hours this will take. So if I'm doing this, I usually start with the available or the total volume, the 500 milliliters. And then I will use my dimensional analysis. If you're doing desired or ordered over available, this also works, but that's not the way I'm doing it. I'm getting rid of milliliters, multiplying by 1 hour. And if I do that right, I should get 4 hours. Sometimes they'll ask you a question like if the infusion starts at 8 a.m. on a Monday and you have this flow rate, when will it end? And you can say it would end at 1200 you know 1200 hours or 1200, because you're doing military time, meaning that if it started at if you started at 0800 and then you added 4 hours, you would end up at 1200 as the time. So you might have to review your military time if that's something that you struggle with. I don't know that they're going to ask you that. I feel like they want you to know that, but it's very rarely that they ask you to incorporate that. Just letting you know, just because, like I said, it was listed there and just wanted to make sure you saw it. So just give me 1 second. Just gotta plug in a device here or the battery goes dead. Okay. All right. Okay, so let's look at some of these now drop rate questions. So with the drop rate questions, we're going to utilize our previous knowledge of flow rate. Then we're going to multiply by something called the drop factor. And that will equal your drop rate. Now, your drop rate is going to be drops per minute. And that's what they even tell you to look for, right? They say, what's the drops per minute? What's the drops per minute? So sometimes you'll see, especially when you get it like next semester, when you do the heparin infusions, it'll say something like a heparin rate or drip rate, a heparin drip rate. So drip rate doesn't always mean drops per minute. Okay. Sometimes the only they'll just use that interchangeably because you could have something flowing at 5 milliliters per hour, which is essentially 1 teaspoon every hour dripping into the patient's IV, right? So it's a slow process. So it's still dropping very slowly, but we can even get down to the more nuanced answer and get a drop rate listed and get that answered without waiting to find out or to give us a bigger number or a little bit more of an absolute value. Now, one thing I'll mention, it may not show up in these practice problems, but if you get a drop rate with a decimal answer, you cannot give somebody a partial drop. Okay. So they get a drop total. So if you get something like 28.5 drops per minute, then you need to round that up to 29. Okay. If it's 28.4, then just round it down to 28. Okay. But with drop factors, they have to be given a whole number because you cannot give someone a partial drop. All right. So let's look at this. So it tells us that we have order to administer an IV solution, 75 milliliters, 25 minutes, and then we have a drop factor, and I have to look at my label of 15 drops per ml. So I'm going to take my volume over my time. Now, you may instinctively want to convert minutes to hours just based off of what I previously showed you to do. Don't do that. Okay. You don't want to do that. You want to take leave it in minutes because your final answer is in minutes. Okay. So don't change that. Then you're just going to multiply that number by the drop factor. So the drop factor is always going to be drops per milliliter. So they tell you drops per ml. The abbreviation for drops is GTT. Okay. And then now I'm going to do is just find my answer. So like I made this simple when I created this question a long time ago. So I know the answer is just 45 drops per minute, but I'm going to take 75 times 15 and I'm going to divide by 25. I'm going to get the same answer, 45. Now I'm doing a bad job of mirroring something that I want you to be practicing if you're not already. In this setup, I've eliminated milliliters and I'm left with drops per minute, which is what I'm looking for. So before I do any math, I already know I'm in the correct unit per measure. Again, if you're I always tell students too, like when I'm personally doing these problems, I just type it into my calculator, I get my answer, and I move on to the next thing. I can't assume that that's where you are um, with your math, because you're not math students, you're nursing students. You're more focused on the nursing aspect and all that is entailed with that, and less concerned about the math. But you have to pass these math tests every semester. So that's why I always treat it this way because I know that there's at least a good 25, if not 50, if not 75% of nursing students that struggle with this math stuff because it just doesn't come as naturally to them. And so I always try and give you a strategy that I know consistently works where there's not much deviation from it. It's one of the reasons why I don't just always do ordered over available. But if you're doing that and you're getting the right answers every time, You do not need to change anything, okay? Like you're organizing it in your own way. You are technically using dimensional analysis, you just don't know it. But if you're ever getting stuck or you find that you, for every practice test, you miss the same type of question, this is where this can be helpful just to how to set up your problem. The other thing is if you're looking for extra problems to practice, don't worry about the extra problems as much as just practicing your setup because the only thing that really changes on the test is the numbers. As long as you know how to utilize and do and work with the numbers, you should be fine as far as answering the majority of these types of questions. So here, I'm going to give you another setup here. I'll have you do number 20. So you can see it's a bigger number. I'll highlight it here so we know we're all looking at it. So take your time, and then when you get an answer, drop it into the chat. All right. So it looks like a number of you are getting the same answer, and then some of you are, what do I do? So let's do it. I'm seeing the recurring answer of 20 drops per minute. That might be right. I don't know off the top of my head. Uh, so I'm going to use the template that I followed for this question up here, flow rate times drop factor. Okay. So what is my flow rate? For what I know right now, I have 1440. It says CCs, but you know, and if you don't know, now you know, CC and ML mean exactly the same thing. So 1 CC equals 1 ML. So I'm just going to rewrite that as 1440 ML. And it's infusing over 12 hours. Okay. Then we have our drop factor. So we have this big number 10, and it tells us 10 drops per milliliter. So my drop factor is just right over here, 10 GTT per ml. So a couple things. So I'm going to show you the common way I think many students work through this. So they usually will just follow what I just showed, which is the 10 drops per milliliter. They'll get drops, but then they'll have drops per hour. And we don't want that per hour there. Okay. So I can do one additional step. And what I can do is I can convert the hour to minutes. I'm going to show you an easier way or a way that's a little bit more concise than what I've written here. Okay. So I'm just going to leave this here. Now let me show you the more concise way. There's two ways that we can simplify this before we get into doing an extra conversion factor. If you look at that and you go, oh no, why do you throw in another one? So the first step I would do is I would take that 1440 ml over the 12 hours, and I would just go ahead and reduce that to milliliters per hour. So if I take 1440 and divide it by 12, I get 120 milliliters per hour. Okay. 120 milliliters per hour. What's an hour? An hour is 60 minutes. So I can actually start here, then multiply by my drop factor, and then I'll be getting the same answer. So milliliters will be gone. I'll be in drops per minute. Okay, so that's strategy one. The other thing is you can take your 12 hours times 60 minutes, and that'll give you 720 minutes. Okay, so you can kind of do that as a prep step. So 1440 ml over 720 minutes times your drop factor, which is 10. So no matter how I dice it, how I set it up, and I'm showing you three different ways just to kind of, if you ever get stuck, I like you to see that there are options. So like the traditional way and like the long way, we'll just call it that, is this. And then we'll get 20 drops per minute. If I simplify the 1440 over 12 first, okay, and I get 120 ml per hour, and you already know that 1 hour is 60 minutes, all we're doing is making that transition, right? Hour, minute. And then do your math, and you get the same answer, 20 drops per minute. Same thing here. If I plug this into my calculator, 1440 times 10 divided by 720, I'm going to also get 20 drops per minute. So I'm trying to show you a variety of options just because it'd be helpful to potentially help you to understand the different steps that you could take. So you can do it we'll just call this the long way. You can simplify, or you can go hour to minute and just kind of keep it like that. So any way that you look at it, you can do this and get the same answer. Okay, which is why I showed you the three different kind of ways. Okay, let's see what else we got down here. I know there's a lot of these things. All right, this is a good one that I saved for now, just because this is a common question I get, but this is something you already know how to do, unless it's your first semester and you haven't done these. But you already know how to do these because you've done this question before. These are oral-based meds. I'm sorry, these are injectables, but you're going to treat them just like oral-based meds. It tells you that we want to give the patient 60 milligrams of Visceral. Let's highlight that. We want to give the patient 85 milligrams of Mepridine, and we want to calculate a total volume, meaning we're going to add both medications together to get a total volume in milliliters. We look at our label and we can see that the Visceral is available in 50 milligrams per milliliter. So I know sometimes it's hard to see that, but it says 50 milligrams per milliliter. That's for the Visceral. The Mepridine, a little bit easier to see, is the 75 milligrams per milliliter. So the M is 75 milligrams per milliliter. So all you're going to do is what you already know, or you should already know how to do, is and this is where you can use ordered over, ordered or available, or desired over have. That works just fine. I'm still going to set this up using dimensional analysis because I like to punish you a little bit, I guess. I don't know. But I'm going to take my Visceral, 60 milligrams is my order, and then I'm going to convert milligrams to milliliters. So 50 milligrams, 1 milliliter, 60 divided by 50, and I get 1.2 milliliters. So I need to give the patient 1.2 milliliters of Visceral, and then I'm going to take my order of Mepridine, 85 milligrams, times my available is 1 milliliter per 75 milligrams. 85 divided by 75. Now this is where I get a 1.1 and then 333, just keeps going on and on and on, milliliters. So what we're going to do is we're going to round this, okay? You can round it now or you can round it later, but really we're just going to be crossing that out because it doesn't raise the number. So then I'm just going to add these two. 1.2 plus 1.1 gives me 2.3 milliliters total. Okay. And then you just write that 2.3 milliliters total. So this is good practice, right? Because now you are practicing something that you've already done previously. but I skipped over it, right? Because I didn't do this. You saw this last semester, unless you weren't here last semester. You saw this type of question last semester, so you might see it again when you take this particular test. All right. Okay. So these next two questions are going to be good to go over, but we're actually at the end of our review time. I'm going to I'm going to have to save these for Thursday when we go together. So if you end up coming on Thursday, I'll go through 22 and 23 just to make sure, and I'll go through those first, and then I'll come back and review the things that I haven't reviewed yet for um next time. So if you did not get the um the review uh test or where to get the information for this, it's in the same however you got the information to come here and where you got this Zoom information, there is a OneDrive link. You click on the Allegheny folder, go to 130, and then that's where all this information will be posted for you. Um, I and this is just a repeat of what I did last semester. So it was a 25 spring review. So there hasn't been much of a change. If you want some additional practice, you can go into the archive folder and there's some old questions in there. Some of them, some of the questions we don't utilize anymore. So what's listed in the 25 spring is the most current iteration of review material. I will be meeting again with at you guys 1:30 class on Thursday at noon. If you have questions, email me. That's why I put it in the chat. Um, and then if there's any other additional reviews that I end up doing, I will let you know. But most of the time, I can answer your questions. If you send me a screenshot or copy paste the question into the email, I can usually just email you. And if I really need to, we'll set up a time via Zoom. But a lot of that just depends on your availability and my availability. So, like I said, the I'll be back again on Thursday. And again, if you have questions between now and next week, email me, please. And then I'll see you guys maybe Thursday.
Thank you.
You're welcome. Hope you found this